Welcome back, Power Masters! It's Justin again, here for another level of, you guessed it, Power Play! We've now completed levels 1 and 2, where we learned to harness the power of multiplication and division through the product of powers and quotient of powers properties. Today we're taking it up a notch with level 3, Power of a Power. Whoa, cool. But first, the discovery activity. If you haven't completed it yet, pause the video here to complete the Power of a Power discovery activity in your PDF. At first glance, I see a lot of powers here. We've got terms with exponents raised to the power of another exponent. Let's talk through this completed example to see if we can make some sense of it. Here we have 2 squared raised to the power of 3. So, if there's 2 exponents, what's the base? Let's break it down into sections. How about inside the parentheses? If we isolate just this section, what's the base and what's the exponent? We have 2 squared, so the big 2 is the base, and the small 2 is the exponent. But what about this small 3? If that's an exponent 2, what's its base? Well, if 3 is the exponent, that makes 2 squared its base. In the completed example, they expanded this outer exponent of 3 first, with its base 2 squared times itself 3 times. Then each of these 2 squares is expanded further into 2 times 2 times 2 times 2 times 2 times 2. So how many total times is 2 being multiplied? 6 times. So the expression is rewritten with a single exponent as 2 to the power of 6. So the exponent on the outside of the parentheses tells us how many times to multiply the base that is inside the parentheses. And once that's written out, we can further expand the expression until all that's left is multiplication. If you have trouble completing the discovery activity before, pause now and try again. And don't forget to make your prediction of what the power of a power property is. Once you've completed the activity, feel free to pause here if you'd like to check your work with mine on screen. Did you notice any pattern between the exponents in the first column and the final exponent in the last column? In the first row, the original exponents are 2 and 3, and the final exponent is 6. In the second row, the original exponents are 3 and 3, and the final exponent is 9. The third row has 4 and 2 as the original exponent with a final exponent of 8. And finally, the fourth row has 3 and 4 as the original exponents with a final exponent of 12. Is there a connection between the original exponent numbers and the final value of the final exponent? Hey, 2 times 3 is 6, and 3 times 3 is 9, and 4 times 2 is 8, and 3 times 4 is 12. These exponents are being multiplied. Let's use an example to further investigate how this property works. We have e cubed to the power of 6. How can I rewrite this with a single exponent? When in doubt, expand it out. Exponents represent repeated multiplication, so first we can rewrite this as e cubed multiplied by itself 6 times. Then each of these e cubeds can be expanded as well. Whew, that's a lot of e's. Now we have e multiplied by itself 18 times. How else can we represent e being multiplied 18 times? E to the power of 18. So just like this exponent tells us how many times to multiply the expression inside the parentheses, we can also get to our final exponent by multiplying the original exponents together. Take a look at the bottom section of your discovery activity in the PDF where you predicted what the power of a power property is, and pause here if you'd like to make any changes. The formula for the power of a power property is x with some exponent a raised to the power of another exponent b can be simplified to a single instance of x with an exponent of a times b, the product of the original exponents. Remember, you can write the formula in whatever way feels best for you. Here's the same property formula shown with shapes instead of variables. And with that, we're ready for level 3 of Power Play.
It's time to master the third of the 5 key properties of exponents. Test your powers by simplifying expressions using the power of a power property.
Okay, task 1. Rewrite the expression with a single exponent. The expression is 3 squared to the power of 5. The power of a power property tells us that when there's a term with an exponent raised to another exponent, we can multiply the exponents. Pause here to put the power of a power property to the test. We'll check your work when you're done. Since 3 squared is raised to a power of 5, using the power of a power property, we can rewrite this as 3 to the power of 2 times 5, which is the same as 3 to the power of 10. How'd you do? As with all the other properties we've learned, we can check our answer by expanding the expression. 3 squared to the power of 5 is the same as multiplying 3 squared by itself 5 times. Then each of these 3 squareds can be expanded further, giving us 3 multiplied by itself, a total of 10 times, or 3 to the power of 10, which is the same answer we got using the power of a power property. We have m to the power of 4 raised again to the power of 4 times n squared to the power of 2. And we need to simplify the expression as much as possible. I notice that there are 2 different variables with exponents, and each of them is being raised to another power. Then, between the 2 variables is multiplication. How do you think we should approach this problem? We're simplifying, so we follow GEMS and use the power properties in that order. According to GEMS, exponents come before multiplication, so we need to simplify each of the components on either side of the multiplication dot first. Pause here to use the power of a power property to simplify m to the power of 4 raised to the power of 4 and n squared to the power of 2. Due to the power of a power property, when there's an exponent raised to the power of another exponent, we can multiply the exponents. M to the power of 4 raised to the power of 4 becomes m to the power of 4 times 4, or m to the power of 16. N squared to the power of 2 becomes n to the power of 2 times 2, or n to the power of 4. Okay, what do you think we should do next? These simplified components are being multiplied, which makes me think about the product of powers property. Can we use that property here? To use the product of powers property, each component needs to have the same base. These bases, m and n, are different. So there's nothing else to simplify other than rewriting this without the multiplication dot as m to the power of 16, n to the power of 4. Level 3's got nothing on us. Last task, again, simplify as much as possible. We have x to the 5th raised to the power of 3 divided by x to the 4th. What do you notice about the bases in this one? both components in the numerator and denominator have the same base. Something's telling me we may need more than one property to simplify this problem. Here's all the power properties we've learned so far. You'll need to decide which property or properties you'll need to use. Remember to follow gems when applying them. Go ahead and pause here to try simplifying this expression in your guided notes. This division has my quotient of powers property senses tingling. But, according to gems, we need to simplify the numerator grouping first. Using the power of a power property, we can simplify x to the fifth raised to the power of 3 by multiplying the exponents. X to the power of 5 times 3 becomes x to the power of 15. Now what? The remaining elements are being divided and have the same base, so we can use the quotient of powers property and subtract the exponents. But how do we know whether the simplified term will end up in the numerator or the denominator of the final expression? It all depends on which element, the one on top or the one on bottom, has the larger exponent. X to the power of 15 has a larger exponent than x to the fourth, so the final term will be in the numerator, and we can rewrite this as x to the power of 15 minus 4, which simplifies to x to the power of 11. This expression can't be simplified any further, so we've reached our final answer. Wow, we're really rocking through these levels. At this pace, we'll be using our new powers to battle the final boss in no time. By this point in the lesson, you should have completed the power of a power discovery activity, and you should be wrapping up the guided notes. That leaves you with the online practice, and if you're feeling powerful, there's a bonus activity included in your PDF, so you can really put your power play powers to the test. Next up, level 4, power of a product. You probably know the drill by now, but it's just too much fun not to say it again. Keep practicing so you can harness the power of the power! See you next time!